Right, so what we can do is we can start looking at some other linear models. And when we talk about a linear model, we're talking about models with fixed parameters. Okay. So you can use a second degree polynomial and you'll get that kind of shape. The old parabola that we used to do at school, right? Now that would probably fit the real response curve a lot better. Okay, so we use the simple linear regression and then, we reached a point where the simple linear regression won't work anymore. So now I've decided I'll go for a parabola. Now it fits the extended curve fairly well. Okay. But then if I extrapolate again, at 50 degrees, I'm going to have -9 micron growth. Okay. Which is why I've got the red question marks there. Again, if I'm going to just work between these points, and I'm not going to go beyond the variables, that model will work. It'll be fine. Okay. But it might be better to go for a nonlinear model. And generally, when we talk about a nonlinear model, it's got an exponential parameter, which gives it the nonlinear shape. Okay. What I've got here, you can see, is basically a parabola, missing its last bracket here. Okay. But I'm using an exponential version of it. So what is it doing? It's coming up, it's fitting, it'll go down, and it will level out there. Okay? And it then, if you look at the, where were we, the R square value of 0.91, there I'm 0.94, not a big difference, but it might be a better fit of reality. Unfortunately, you're never ever going to get down to 0, okay? But you're going to get close to 0. So at least it's a better and a closer fit. Now, why do we want to do that? Obviously, we want to get some quantitative model of the relationship between variables, but then we also want to start applying it in some biological way. Now, just to give an example of what we do, we have what we call escape resistance. Now, we don't have resistance when it comes to sclerotinia. We don't have resistance like you do in with rust. Okay, it's an unspecialized pathogen, and it can colonize. Well, the last figure I saw was something like 400 different hosts. And okay, so now I want to know whether varieties have any form of resistance. Now, we know that they're all susceptible. Do they have some level of tolerance? Do they have some level of escape? Are there some environments where, or some cultivars where in a high disease potential environment, they'll have a reduced risk of disease? Now, something like regression analysis becomes very useful. I have 30 cultivars, soybean cultivars, 3 localities, 2 planting at each locality, early and late. So I've got basically 6 environments. I want to quantify the environment. So what I do is, seeing the genotypes are all, or it's the same genotype in each trial, I take the mean of the trial at a specific locality, and I use that as an indication of what I call disease potential. Okay. So all cultivars associated with a locality and planting, I take the mean, and it gives me a quantification